Hi, well thanks for joining me again. I'm Joseph B.H. Macmillan, and this is the third in a series of videos I'm doing called A Legal Proof for the Existence of God. In this video I'm going to be looking at the science in Genesis Day 2, and that is what scientists call expansion. Now this concept of expansion is important, and Day 2 is important because it relates to the second part of converting the quantum laws of physics into the classical or Newtonian laws of physics that create the world and life we see all around us. Why expansion was important is because after the initial inflationary burst and the Big Bang, all the matter created was dispersed in the embryonic universe. Now, if there hadn't have been an expansion force to counter gravity, gravity would have pulled back all this matter into a gravitational singularity again, and there would be no universe and there would be no us. So that's why this part is extremely important. But before we get on to that, let me just say what I will not be doing in this series of videos. I'm not going to adopt the intelligent design argument, which essentially substitutes God for what they say science can't yet explain, because more than likely science will come up with an explanation. And as we're going to see when we get to Day 3, that has already happened, and in a very devastating way, because intelligent design, by focusing on evolution and saying it is highly unlikely or impossible that life could have evolved on this earth, they said that means God must have created life. Now, the problem is science has now discovered that yes, they're probably right about that. Life is actually created in space, but the problem is the scientists now say that they know how the laws of physics created that life. So although the intelligent design argument may prove to be right, that life didn't start on Earth, all that's going to happen is science is going to show, yes, you're right, it started in space and this is how it happened. And that is the danger of building a case on the wrong evidence, because when that evidence is shown to be wrong, your whole case simply crumbles all around you. Lawyers are very aware of that. And that is why what we're going to be doing in these videos is showing that the scientific, philosophical and scriptural evidence all come together to prove beyond a reasonable doubt, in the legal sense, the existence of God. But before we get on to Day 2 itself, I'd just like to recap on the methodology that Genesis used in Day 1, because this is a methodology that is used throughout the creation story in Genesis. So let's just remind ourselves of what that was, because this is important. So what we saw in Day 1, we start with the beginning, where it says there's the heaven and the earth, and that's clearly space and matter. And it says this space and matter is without form and void, and darkness was upon the face of the deep. What it then does is re-describe the space and matter, heaven and earth, collectively as the waters. It's talking about the Spirit of God moved on the face of the waters. So the heaven and earth are just re-described as the waters. The waters are then converted into light. Let there be light. And there was light. And that is consistent with the science. Because as we saw in Day 1, with the inflationary expansion and the Big Bang, billions and billions of particles and antiparticles were spewed out into this expanding universe, and the particles and antiparticles collided with each other and created photons of light. But now, there was a slight excess of particles over antiparticles, and that is clearly referenced here by saying, and God divided the light from the darkness. The light is the photons of light, the darkness is the particles, the matter that was not converted into light. And so there we see there's this constant redescribing of something that then is converted into something else and then redescribed as something else. And that's very important when it comes to day 2. Now, there are people that are going to say, well, that's a rather creative interpretation of the first day of Genesis. But the remarkable thing is it's not that creative. It's actually a literal reading of those words if we understand the methodology. And the reason we know that is because long before science knew anything about inflationary cosmology or anything like that, a Jewish scholar, Nahmanides, this is over 800 years ago, by adopting a literal reading of Genesis, came up with precisely that explanation. Now, what Nahmanides says is actually very, very fascinating, remembering that this was 800 years ago, before any of the science stuff was even thought about. And let me look at an iPad to read what he's got to say, and to make clear that he's taking a literal reading of Genesis. This is what he says. And now listen to a correct and clear explanation of the text according to its simple understanding. That makes it clear he's taking a literal reading. And then this is what he says about that. Let me see if I can get it here. The heavens and all that is in them are one material, and the earth and all that is within it is another material. And the Holy One, blessed be He, created both of them from nothing, and the two of them alone were created, and everything was made from them. He brought out a very fine element from complete nothingness. It has no substance, but it is the energy that can create, that is able to accept a form and to go from the potential to the actual. And then on Genesis 1 verse 1, he says this, and behold, with this creation, which was like a small and fine dot and without substance, were created all of the creations in the heavens and the earth. Now that is amazing. That was 800 years ago, before science had any idea about inflationary cosmology, the Big Bang, the expansion, anything like that. And just a literal reading of those few verses in Genesis comes up with that. Of course, if you could understand the Hebrew, maybe it'd be a lot clearer. Now, why it's important is because the first day of Genesis gives us the whole basis of the mathematical equation, and we must remember the universe is basically based on mathematical laws. It gives us the equation that says a substance can be changed into a different substance or a different form without losing its intrinsic value. I mean, that's the basis of the most famous equation of all, Einstein's E equals mc squared. But it also gives us the basis of morality, which is freedom under law. Freedom subjected to a law, just as happened in Genesis day 1. The freedom of particles to do as they please in the initial gravitational singularity had a law imposed upon them. And that's the same. So we move from a position of freedom, as in human life, absolute freedom, but absolute freedom would lead to absolute chaos, and we have a law imposed on it, that there are certain aspects of that freedom which have to be limited. We recognize obligations that limit that freedom in order to be able to live together and have order and security. So now let's get on to the meat of this particular video, which is day 2. Right, so let's look at what day 2 has to say happens next. Remembering that day 1 ended with light and darkness. That's photons of light and the particles left over from the grand annihilation. And the first verse describing what happened in day 2 says this: "And God said, let there be a firmament in the midst of the waters, and let it divide the waters from the waters." So the first question is, well, what has happened to the light and the darkness? I mean, where did the waters suddenly come from, and what on earth is this thing called a firmament? Well, that's why I wanted to recap on the methodology, because quite clearly what the waters mean is the light and darkness that was left over from day 1. It's just re-describing the light and darkness, the photons of light and the leftover particles, and that is to emphasize their latent life-giving properties. Yes, so let's try and work out exactly what the waters were then. So what they were the photons of light plus the particles that couldn't find an anti-particle to convert itself into a photon of light. But there's another element to the waters, and that is dark matter. And darkness may well refer to that as well. And what this dark matter is, I mean, scientists don't know for sure what it is, but the reason they know it's out there is they know that with the amount of ordinary matter, that's the particles that make up the atoms, etc., that make up the world, the universe that we see, the stars and galaxies, well, they just don't produce enough gravity to create those stars and galaxies and planets, etc. So they recognize that there must be some other matter there, and it's just matter we can't see, and they call this dark matter. Now there's a further element to this, because the waters, we could now say, represent the particles that were left over, the photons, and this dark matter. We don't know what it is, but it's out there. But the particles, by this stage, had formed into the first elements, but they'd only formed into the lighter elements, because the heat produced by the Big Bang was not sufficient to force the particles to adopt the structures that would create the heavier elements and atoms like iron. And let's just have a look at what Brian Greene then says these elements would have been at this stage of the universe, the unfolding universe. And what he says is this: by the time the universe was a couple of minutes old, it was filled with a nearly uniform hot gas composed of roughly 75% hydrogen, 23% helium, and small amounts of deuterium and lithium. So the particles that were left over, that couldn't find an antiparticle to collide with, were at this stage converting and forming basic structures of hydrogen, helium, little bits of deuterium and lithium. And so all of this was now expanding outwards. All of these materials, they were everything that would create the universe and life as we know it. But as we saw at the beginning, there's a danger, because if there's nothing else, gravity is going to take all this stuff and just squash it together again into a gravitational singularity. But the strange thing is, when it talks about the waters, it's talking about separating the waters, and we'll see that in the next segment. Because at this particular stage, all of this matter and light and everything is expanding, and it looks almost uniform. Let's just see what Martin Rees says about this. Yeah, because at this stage, it's very important to recognize this particular point. It says, when the universe was 1 million years old, everything was still expanding almost uniformly. And that is important, almost uniformly. So what we have now, before we look at the next verse, is we have photons of light, we have these initial elements, and we have the dark matter. They're expanding almost uniformly as following the Big Bang. But as we saw, there's something very important now, because if something doesn't intervene, all of this stuff is just going to squash in again. And so that's what we have to see, what Genesis says happens, that prevented this collapse of the universe at this early stage. Right, so let's just see what happens to the waters. Just remind ourselves of the verse again. Because what it says is, and God said, let there be a firmament in the midst of the waters. Now, what on earth is this firmament? Well, I have a little note here that tells you to have a look at the side, and what it says is Hebrew expansion. So it says put an expansion in the midst of the waters. Now, of course, until these guys, Alan Guth and Henry Tye, proposed the theory of expansion in the 1970s, you can see why the translators of the scriptures would have thought, well, expansion, that's a pretty silly word to stick in there, so let's call it a firmament. Others have called it a vault, an expanse, a canopy, all sorts of funny things. So of course, when Tye and Guth proposed the theory of expansion, and that was to overcome shortcomings in the conversion of elements, etc., to the heavier elements from the Big Bang, people ran around trying to work out, well, is the expansion referred to in the original Hebrew, and the word is rakia, the same thing as what science now calls expansion? And of course, the view taken by this person or that person depends on what they want to prove. But luckily in law we got something called the best evidence rule. And that rule says that you use the best evidence to try and prove your case. And so, for example, in a contract, if you use a particular word or phrase, you don't go and look to see what somebody 20 years or 50 years later thinks that the people meant when they put that word in. you look for some contemporaneous evidence or evidence nearer the time to say what they actually meant by using this word. And here we come again to Nahmanides, talking precisely about this particular word. Let me read again from this iPad thing what he said about that. And this is what he says, and he's talking about God. He said about the material that existed at the beginning, when he created it from nothing, that it should be stretched out like a tent in the midst of the water and separate the waters from the waters. Now that's over 800 years before Guth and Tai even proposed their theory. Yeah, and that's remarkable, because let's just have a look at how a physicist describes what the expansion does. And this is Brian Greene again. And he says this: the tremendous outward swelling resulted in space being stretched, enormously large and extremely smooth. The word there, stretched, right? And again, this is Brian Greene. He says, and this is almost identical to Nahmanides, calculations show that the nugget of space need only to have been tiny, to the order of 10 to the minus 26 centimeters across, for the ensuing cosmological expansion to have stretched it larger than the universe we see today. Stretched it larger than the universe we see today. So that's identical to what Nahmanides says. So it tells us that into this almost uniformly expanding universe, something happened, and science acknowledges they don't know for sure what this expansion force is, because we call it these days dark energy, but it's essential, as we saw, to ensure we have the universe that we have today, and to prevent it collapsing in on itself. And so we have this expanding universe with the photons of light, the lighter elements we saw, and the dark matter. And it's into this that God is said to have inserted this thing called a firmament, and what science calls an expansion. They are exactly the same thing. And as we've seen, the original Hebrew word for it, rakia, actually means expansion. So let's now see what this expansion does to this matter and space that it gets put into. Right, so let's see what Genesis says happened next. And we find that at verse 7. And it says this: and God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament, and it was so. So what that suggests is, when it refers to waters being under and above, that the waters weren't uniform. So we should remember what the waters here are representing. It's the photons of light, those particles that couldn't find an antiparticle to collide with and turn into a photon of light, which then became the lighter elements, and dark matter. And we should also remember now that although this was expanding and it appeared uniform, as Martin Rees said, and we saw in the previous segment, it was almost uniform. So it wasn't perfectly uniform. Now, to understand why that is the case, we have to look to see what happened in day one, because this was a pre-existing state of affairs, because the waters came over from day one. And to find out why there would be this non-uniformity, we look to what Brian Greene has to say about it. And he says the initial non-uniformity that ultimately resulted in the formation of stars and galaxies came from quantum mechanics. Now we should remember that when we're talking about day one, we're talking about the gravitational singularity. All matter and space was all condensed into one tiny point. But within that, there were these fields, and they were subject to quantum principles of quantum physics. And it was like, the field's like a little worm wriggling around, different energy at different times. And this is how Brian Greene explains the energy concentrations within the singular gravitational singularity. The amount of energy in one location would have been a bit different from what it was in another. Now, that's actually confirmed by measurements, because what it tells us is that with the inflationary burst, these slightly different energy concentrations were amplified into the expanding universe. So some parts of the universe were more dense in particles and energy than others, and we know that because we can measure the temperature differences in the background radiation in different parts of space. And this is how Brian Greene explains that. He says, the observations have shown that these tiny temperature differences fill out a particular pattern on the sky. So they had an effect across the entire universe. So the way to think about it is like a swarm of bees or a swarm of locusts. When you see the swarm lift off, it just seems like one big mass. But as it expands, we see darker areas and lighter areas. The darker areas just simply means there are more bees or locusts in that area than in that area. And so as this expands, it has a bigger and bigger effect. And when we try and work out where this came from, it came from the inflaton field that we looked at. That's the field, like the little worm, that was in the gravitational singularity. And the reason it does this, according to Brian Greene again, he says that the inflaton field reached the value of lowest energy at different places at slightly different moments. In turn, inflationary expansion shut off at slightly different times at different locations in space, so that the amount of spatial expansion at different locations varied slightly. Yes, so that's the picture of the universe at this early moment. We got all this matter expanding, which Genesis calls the waters. But as it expands, they're separating because there's more dense and less dense areas. And we can see, according to Rees, what effect that has, and it's a very, very important effect. And this is what he says. The slightly overdense regions, expanding slower than average, were destined to become galaxies or clusters. Others, slightly underdense, were destined to become voids. Now that's important, destined to become voids. What was happening is the matter is pulling itself together with gravity. The expansion, or the firmament as it's called in Genesis, is pushing it apart. So as it gets expanded, the denser regions are heavier and are pulling together. The other regions are pushing apart. And so slowly we get these clusters, and that starts leaving these voids. Now, let's just read what Martin Rees says about this, and this is interesting. He says, the fierce repulsion that drove inflation must have switched off, allowing the universe, having by then enlarged enough to encompass everything that we now see, to embark on its more leisurely expansion. So that is very important, because what it does is it confirms the Genesis account and the difference between day 1 and day 2. Talking about inflation switching off and expansion starting after that exactly reflects Genesis, because we start off with the gravitational singularity. We then have this inflationary burst that causes the Big Bang, and all the matter is scattered across space, but not uniformly. More dense here, more dense here. As it expands, it causes spaces. But then the expansion force kicks in and starts pushing everything apart. And is that separation that's very important, because it explains an apparent, obvious omission in day 2 of Genesis. And that we find in the next verse. Right, so let's have a look at that verse, and it actually also happens to be the last verse of day 2, and it's verse 8, and it says this: and God called the firmament heaven, and the evening and the morning were the second day. Now, the remarkable thing about day 2 is it does have, as I said, this apparent, obvious omission. Every other day refers at least once to the words "and God saw," but it doesn't appear at all in day 2. But there's actually a very good reason for that, because we must remember what we saw in day 1 is the words "and God saw" represent an observation, and that locks in the state of affairs as at that time when the observation is made. And we don't have it here. And the reason is actually very simple, because at this stage all we have is the photons of light, we have the lighter elements, and we have the dark matter, and they are now forming into these proto-galaxies, these huge clusters. But there are no heavy elements, so there can be no life, because you need the heavy elements for life. And the most interesting thing is day 3 of Genesis, as we will see, links the creation of the heavier elements with stars and supernova and life. And science is now beginning to make that connection as well. So it was fundamentally important at this stage that the whole thing is not locked in. Otherwise we would have simply ended up with huge proto-galaxies and clusters with the lighter elements and nothing more. This expansion and this concentration of matter had to carry on so that it could condense and create the stars and the supernovae that would then create the heavier elements and life as we know it. Without that expansion, nothing would exist today in the way it does. So it was fundamentally important that the expansion, the universe, had to continue, as Rees says, with its more leisurely expansion until such time as we could get to the stars and supernova and life. Right, to conclude day 2, I just want to mention 2 final things. The first is the naming, where it finishes in day 2 and it says God called the firmament heaven. That's the first point. Because as we saw, this naming which only happens in days 1, 2 and 3, represents the conversion or subjecting part of the quantum principles into the classical laws, the quantum laws into the classical laws. And the naming is always with the capital, as it is here, H for heaven. What the heavens clearly represent are the voids. Let's just go back to what Martin Rees says, the quote we looked at earlier. When Martin Rees says this, let me find it, I beg your pardon, and it's here. The slightly overdense regions expanding slower than average were destined to become galaxies or clusters. Others, slightly underdense, were destined to become voids. Now clearly when it talks about the heavens here, it's talking about the voids. The voids. Once the densities of matter form into these clusters and galaxies, the rest is what we regard as empty space, the voids, and it calls them the heavens. And why this is important is because the expansion is an integral part of the classical laws of physics. Without the expansion, we wouldn't have the voids, and we wouldn't have the clusters that we're now going to go on to form the heavier elements and life. So it is quite obvious that by naming the heaven and putting it with a capital, we're talking about a situation where part of the principles of quantum physics had been subjected to a law and converted into the laws of classical physics. So that's an important point, because it's the basis on which the next part of Genesis happens, and the same as with science. And the final point then is we're talking about a time span, and the evening and the morning were the second day. Now it's exactly as we talked about in day 1. Martin Rees has these diagrams, as do most scientists, depicting the time scale of the universe, and it starts with a little dot down here and then this huge funnel that goes out showing the universe to where we are up here somewhere. And at this point we find the photogalaxies. Well, where did they come? Well, it seems to be around about 1 billion years. So that's the measure of day 2, 300,000 years for day 1. So it's 1 billion less 300,000 is the time span that Genesis is talking about here, and it just happens to agree pretty much exactly with science. So what we're going to do in the next video is look at day 3, and what Genesis tells us about science in day 3 may just surprise you.